Hey, Miss Smart here with tonight's assignment, page 72, numbers 1 through 5 from Unit 6, Lesson 9. All right, number 1, which statement is not true for the function f given by f of theta is equal to the sine of theta for values of theta between 0 and 2 pi? So we're looking at the sine of theta. So the outputs of the function range from -1 to 1, and that is true about the sine of theta. Goes from 0 to 1 to 0 to -1 back to 0. So we're looking for what is not true. So this is not true because it's true, so not A. The sine of theta equals 1 only when theta is pi over 2. And that's true. This is the only time that the sine is equal to 1. These are equal to 0, and then down here is -1. So that's not true. And then C, the sine of theta is equal to 0 only when theta is equal to 0. That one is not true because the sine of theta is equal to 0 in both of those places, when theta is 0 and when theta is pi. So I think we found the one that's not true. C is not true. And then just to double check for D, the sine of theta is greater than 0. This means when theta is between 0 and pi. So that's the top half of our unit circle. Between 0 and pi, from there to there, the sine of theta is greater than 0. So above this, it's positive, 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 then 1, then still positive, 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 and then back to 0. So that last one is true, so it's not true. So only C is the answer for number 1. D, angle theta measured in radians satisfies the cosine of theta is equal to 0. What could the value of theta be? So when does the cosine of theta equal 0? So cosine is our x coordinate. It's equal to 0 at 2 places on the unit circle, right here and up here. So pi over 2 and 3 pi over 2 are the 2 times where the cosine of theta is equal to 0. So that would be C and E. Okay, next, number 3. Here are the graphs of the two functions. Which is the graph of y equals the cosine of theta? Explain. And then the sine of theta and explain. So I know this graph here that starts at 1 decreases to -1 and increases back to 1. That is y equals the cosine of theta. So it's graph 2. And I know this because the cosine of 0 is equal to 1, and that's this point right here is at 0, 1. Okay, so that's how I know that is the cosine graph. And then for, obviously the other one is going to be y equals the sine of theta. So this graph here starts at 0, increases to 1, then decreases to -1, and returns back to 0. This is graph 1. It's y equals the sine of theta. And when I'm trying to determine that, I always look at that y-axis to just see where is the function starting. Is it starting at 0 or is it starting at 1? So since this one is starting at 0, that's how I know it's sine, because the sine of 0 is equal to 0, and this point right there is 0, 0. When theta is 0, the sine of theta is 0. When theta is 0, the cosine of theta is 1. Okay? All right. Number 4. I'm going to try and show the graphs and number 4 at the same time because it's asking us questions about the graph. So let's go ahead and make sure we can see them. So for number 4, which statements are true for both y equals the cosine of theta and y equals the sine of theta? So both of those are periodic functions, so we should circle A. Both of those have a maximum value of 1. See, neither of these graphs go past 1, so we should circle B. The maximum occurs at theta is equal to 0. Only true for cosine, not true for sine, so don't circle D. The period of the function is 2 pi. Cosine, here's the beginning of the cycle, here's where it ends. The period is 2 pi, so true for cosine. For sine, here's where the cycle starts. And then maximum, minimum, and back to where it started. Also, in a horizontal distance of 2 pi, so it also has a period of 2 pi. So circle D, true for both. The function has a value of about 0.71 when theta is equal to pi over 4. That is true. We did that in class today. That's the one point where the two functions are equal to each other and they both are at that root 2 over 2, which is about 0.71. So circle E. And finally, the function has a value of about 0.71 when theta is equal to 3 pi over 4. So 3 pi over 4 is here. So true for cosine, not true for sine. Wait, other way around. True for sine, not true for cosine. So do not circle F. It's only true for sine, not cosine. All right. Number 5, the last problem on your assignment. Here's a graph of a function f. The function f is either defined by f of theta is equal to the cosine squared of theta plus the sine squared of theta, or f of theta is equal to the cosine squared of theta minus the sine squared of theta. Which definition is correct? Well, we graphed this one in class today. It was on that Desmos at the end of our class period. And we saw that this is actually a true thing. We saw that that's actually a true thing because when we graphed that, we got a flat line at y equals 1. So it's definitely not this graph since this isn't a flat line at y equals 1. So that means, well, if it's only going to be one of those two, it must be this one. Okay? And if you are like, how do I know for sure that that's true? Let's see here. I'm going to go back to the Desmos activity for today and look at that right here. And on that first screen, this is what you were working with. We're talking about the last equation. So this is what it looked like when we saw it in class today. It was a flat line. Let me make this a little bit bigger. It was a flat line at y equals 1. And then if I change this minus, or this plus right here, if I change it to a minus, now it looks like the graph that's in your textbook for number 5. So it is definitely y equals cosine squared of theta minus sine squared of theta. All right, that is the end of your assignment. And so the end of the video.